Oh yeah, we're going to look at some stuff with applications to similarity. This is kind of the usefulness of just telling you whether or not things are similar or not. Um, so everything we're going to look at is mostly just based on heights and distances of objects, obviously. And all this stuff we already know two things are similar by usually angle or side angle side or side side side. So for all this, we're assuming that, well, we're either told that they're similar or we just know that they are, okay? And then we can use that idea of similarity to be able to solve different word problems. So for example, let's say we've got a tree with the height of 4 meters, casts a shadow of 15 meters long on the ground, okay? So if I was to draw this, I'm not a very good drawer, but that doesn't matter. So here's my tree. It's casting a shadow out here, 15 meters, and again we know that the top, from the top all the way down is 4 meters. So maybe not very proportional here. So this is 4, and that is 3. Here, I'll put this in different colors. So we'll go 4 and 15 here. And then we have another tree that's somewhere that's casting a shadow that is that's 20. So it's casting a shadow that's 20 meters. We've got this tree here. And again, I don't know how tall this is. I know that the shadow's 20, but I want to know this. So I know these are similar because the angles that's being created, like if you drew a line from down here, that's the angle of the sun that's causing the shadow here. So this angle are all going to be the same, and same thing with this. So I know these are similar. So because we know these are similar, I can just take their sides and write what we call a proportional statement here. So what I would do is I'd go 20 over 15, because that's going to give me the length of the shadow gives me what I need here. And that's got to be equal, because these are similar, it's got to be equal to this question mark, which I'll just use x instead, over 4. So really I need to find out what this proportion is and then just times it by that. Or you guys have probably seen these type of proportions where you're just going to take the 4 over here and times it by the 20 and then divide by 15. So, and that's fine. You can do that however way you want to do this. So I'm gonna actually go and take 4 times 20. So again, I'm going to times by 4, which will get rid of that. And so that'll give me 80. Sorry, that's an 8, 0, over 15. And so I just need to know exactly what 80 divided by 15 is, and that'll give me that height of this. And so when I do that, I get 5 1/3 is what I get for that. So this is going to be 5 1/3 meters is what we're going to be as the height of our tree here. Okay? And so you always want to write those proportional statements. Make sure that if you go the bigger shadow over the smaller shadow, that you go the bigger tree over the smaller tree. Okay? Otherwise, it will screw things up a little bit if you go the other direction. Okay? All right, let's look at another one here. So this one, I got a statue that is honoring Kobe Bryant. Can be found in Los Angeles near the Staples Centers. So we're going to use the information to find the height of that statue. So I put this here. This is the statue over here. So the statue's over here, and then you're standing here. So if you're 1.8 meters, and let's say that you put like this mirror down here, and you can see the top of Kobe's head over here, and you know you're 2.4 meters away from that mirror, we can actually use this information because this angle of reflection and this 90 degree is going to be similar. We've got 2 triangles here. So I just need to set up a proportion here. Again, I want to take, I'm just going to set up my proportion. So if I start with my big side here, I'm going to go 4 over 2.4, and then that better be equal to x over 1.8. Okay? And so then we're just going to solve this. Again, I can just take and times 4 by 1.8. So just cross multiply here, 4 times 1.8. And then I'm going to divide that by 2.4. So divide by 2.4. And so we get x is equal to 3 when I solve that. Again, I went 1.8 times 4, and then divide it by 2.4. So I just, again, cross multiplied that over. It gave me 7.2. And then technically this is 2.4x. And so I divide by 2.4 when I go to solve this. Just to show you how to do that. And that's where I get the 3 from. So we figure that Kobe's statue is 3 meters tall. Okay. Next one here, I've got a flagpole that casts a shadow. So I've got a flagpole here. Again, if I draw my picture here, so my flagpole here. We know it's 40 feet, and it casts a shadow. Let's just say that shadow's cast this way of 25 feet. And then we've got a building nearby. Find the shadow cast by 200 foot. So we've got another building here that's 200. Here's the building. We want to know what this shadow is over here. Okay, so again, just set up your proportion. We'll go to the big side, so 40 over 200. And then that has to be equal to 25 over x. Again, I'm just going to cross multiply, so 200 times by 25. So 200 times by 25, which is going to give me 5,000. And that's got to equal 40x because I multiply that way. So then I'm just going to divide by 40. And that'll give you how big that shadow is going to be, which we're going to get x equal 125 when you actually divide those. So 125 feet is what I get from that one. So hopefully this should be pretty simple. I always try to set up these proportions. It just helps me keep things straight here. Let's look at one more. This one I did because it has a triangle within a triangle, and sometimes it confuses students just a little bit here. So this is a diagram. I've got a metal brace that I've got to put a stabilizer in here. So this stabilizer right from here to here is what I'm putting in the middle. And so what I'm going to do is I've got an 18-foot base on here, and I'm going to go down 4 feet on the left and put the brace, which means, and then there's 6 feet down here. So really I've got this top triangle here, okay, which again, I'm just going to draw this separate here. There's an X here. I want to know what that length needs to be. And I've got this 4. And then I've got the bigger triangle without that small side in there, which this is 18. And then you got to know what this side length is. It's not 6, guys. 6 goes from here to here. This is actually 10. And I think if you draw them out like this, it makes it a whole lot simpler. These are similar because this angle's similar in both. And then because this is parallel, it's going to be the same angle as down here. So we're just going to set up our proportion. Again, I'm just going to go 4 over 10. And then that's got to equal x over 18. I just went 4 to 10, x to 18. Make sure you go from one object to the other. Then I'm just going to cross multiply. So 4 times 18, and then I'm going to divide that by 10 when I'm done. 4 times 18 is 72. And again, that gives me 10x, but then I'm going to divide by this by 10. And so I get 7.2 is what x is. And that would be in feet at that point. So 7.2 feet would be that brace that I'm going to have to put in there. So I know that I've got to buy that much material to be able to support that. So that's what we're looking at here, guys. It should just be that you're trying to use this idea of similarity to find distances and lengths. All right, Math Moment with Mummy out.